All right. Good Friday morning to you. This is just section 3 of your notes. We did section 1 and 2 the other day. Just going to show you where I'm at. Ran up to the school to grab your Africa test. Going to run those through the grading system. Figured I'd record my lesson while I was here for old time's sake. Um, Anyways, just let's go through these notes very quickly, and then we can go ahead and be done for today. So this is section 3. Section 3 is human environment interaction. If you remember from section 1 and 2, landforms and resources and climate and vegetation, that this region is a very, very, very dry region. As you can tell even from this photo here that there's not a lot of green. Maybe in the coast of Turkey, over here by the rivers, Tigris and Euphrates rivers, not too much green in this region. So because of that, water is very scarce. So one way that humans and the environment interact is by the way that they find, use, help contain, and make more of water for themselves. So we're going to talk about a couple of those ways today for human environment interaction. Water crisis in the Middle East. This is a short video. We're not going to watch all of it. You can watch all of it on your own time if you'd like.
The Middle East is the driest region on Earth, with 12 of the world's most water-scarce countries. Water availability per capita from rain, rivers, and underground sources is 6 times less than the world average. And that amount is expected to be slashed in half by 2050. There are lots of reasons for the crisis. They include climate change and increased demand for water as populations grow. Poor resource management is a problem, and so are wasteful agricultural policies. Water is being lost due to overuse of groundwater, outdated irrigation methods, and even leaky pipes. And that's a problem in a region where 85% of water is consumed by the agricultural sector. Water scarcity is also affecting regional security. In Syria, a devastating drought in the late 2000s triggered the mass migration of 1.5 million people from rural to urban areas. Analysts say the discontent that followed contributed to the 2011 Syrian uprising. More recently, local protests sparked by water shortages have been spreading throughout the region. The hotter temperatures and diminished rainfall from climate change are only expected to make the crisis worse, and those stressors are likely to turn more and more of the region's arable land into desert. That could threaten the food security of hundreds of millions of people. Regional countries are responsible.
All right, we'll talk about the ways that they've responded here in just a second. Let's go ahead and make this full screen again. So, as you saw there, fresh water supplies are available in only small amounts. A lot of people say they might run out by the year 2050. So countries have to figure out how to provide fresh water for drinking and farming to all their people. And one way that they've tried to do that is Turkey up here. This is Turkey. They're kind of the start of where the Tigris and Euphrates are. You can see here, here's the Tigris and Euphrates. They're going up here. As you can see, that the Tigris and Euphrates start up there in Turkey, and so they dam some of those rivers to help then they can control the water. But the problem with that is that affects these people downstream in Syria, Iraq. It affects these countries because they're getting less and less water. So they're trying to make laws to where Turkey can't make dams. So they are controversial because they affect multiple countries. Okay, then we go here. Another way that they were about to say there is they tried to conserve water. One of these practices is, you can see here, this is what, if you go out here like by Lawson Road right here off of Highway 80, there's a big old field there, and you'll see one of these things. This looks like a gigantic swing set here, but what it is, it's just a big thing on wheels, and it has little hoses coming down from that, and those things will go in a line and spray water just like a sprinkler, like a water hose sprinkler, okay, hanging down from this pipe. That's how, if you have a lot of water, you can waste some of that water by using heavy-duty sprinklers. When you don't have that much water, then they have to do other things. And what Israel in specific and other countries out there are starting to do is called drip irrigation. It's where you have little tiny holes in this hose here, and just little bits of water gets out. So you're not going and watering all this land that doesn't need to be watered surround it. You're just watering where your crops are. Unlike this land, you're watering everything, okay, with these big sprinklers. Okay, another way that's doing it is desalinization. And what desalinization means is when they remove the salt from the ocean water and make it into drinking water. The problem with this is you have to be next to the coast to be able to do this. And so Turkey's doing a little bit, but really the big country that's doing it because they have money, because it's really expensive, is Israel. Israel's right here, and they're taking water from the Mediterranean Sea, and they're running it through a big plant. We'll show you in just a second. Big plant, and that removes some of the salt from it and makes it to where it's drinkable water. Now, very basic forms of this, like this, wouldn't remove enough salt, and so they use it for like the sewer, use it for maybe agriculture a little bit. But the big plant that Israel has now can remove it to make it where it's drinking water. So it gets rid of the salt, puts the salt back in the ocean, and they have drinking water here. I'll show you a video of that in just a second. And then the other way is fossil water. Fossil water is the water that's in aquifers. The problem with that is aquifers are usually refilled with rainfall, and if we saw here earlier when we talked about climate, they don't get much rain in a lot of these regions, and so these aquifers are running out. Whereas you and I get water from aquifers sometimes. Well, I guess we get it more from Lake Ray Hubbard up there, but wherever we get our water. But some people get it from aquifers, and especially the Middle East does, and those are all going to run out in probably 20 to 25 years. I'm just going to show you what this plant looks like that I was talking about. We're not going to watch all of this video either.
It's nothing short of a man-made miracle. Most of the water that leaves your tap today in Israel was in the sea this morning. This is Sorek, the largest seawater desalination plant of its kind in the whole world. And I am here for an exclusive peek at how a tiny country in the middle of the desert is leading the way in liberating humanity from dependence on rainfall. So here's how it works. First, the water is drawn from the Mediterranean through a pipeline way out at sea. It gets here by gravity alone into this well, dragging some fish, jellyfish, and even the odd baby shark with it too. Half of the plant is busy just cleaning the water before desalination, and pollution from dirty rivers in Israel and sewage from Gaza is testing these facilities' ability to function. Last year, the health ministry briefly shut it down over such concerns.
So they run it through this plant.
Thicker than 5 square millimeters.
Purifies it. This plant purifies the water for a while, and then it gets to these things. These filters right here. Yeah. These filters right here where the magic happens. That's where the actual they have filters that only allow water molecules to go through, not salt molecules. And so that's kind of what this is showing you right here. These things are what takes the salt out of the water. And so that salt becomes drinkable water, or salt water becomes drinkable water. And it's all through this process called desalinization. Very big plant, very expensive. Israel is one of the few places in the world doing that. Okay. Then the other ways that they're interacting with the environment is with petroleum. Petroleum is plants and animals and fossils that are pressure and heated over lots of years and turned into oil. Oil isn't like, contrary to what sometimes we think, oil isn't just like in a big pool underground like that aquifer is. It's trapped inside the pores of rocks. And so it takes a lot of equipment and expensive equipment and a lot of smart people to set up these things, to set up these oil derricks that then suck the water. It provides so much suction that it pulls that oil out of the pores. Okay, so crude oil comes out of the ground, and crude oil means oil that's not been processed. It's crude. It's basic. It's like me squeezing an orange and orange juice coming out. Like, that's not what they sell in stores. That's kind of just the basic orange juice coming out of an orange. You process it in other things, and that's what makes it into orange juice. Okay, the refinery comes into place. It takes the crude oil and converts it into lots of different products as well. And so you have these products that come up like gasoline, kerosene, other things that they're making are byproducts of this oil that they're getting out of the ground. Okay, but the big problem with the human environment, the environment aspect of this, is that these plants when they transport these things, sometimes cause big oil spills or just problems for these plants in general. You have big oil spills happen, like in the Gulf War. You can see here during the Gulf War in the Persian Gulf, they spilt oil out into the Gulf and even lit fire some of their oil refineries there to stop the troops coming in from taking over Iraq. The Iraqi troops set them on fire, so it kind of would slow down the United States people as they tried to fight through all that. Okay, so that's human environment interaction. I'm going to post your vocab quiz, and also there's a short thing here. I'll show you this assignment. It looks like this. It's called the true size of, right here. And what it's going to tell you to do, I'll post the link to get to this web page. I forgot to post it on the instruction page, but it's super easy, kind of interesting to see the true size. Oh, there it is, thetruesize.com. So you go to the truesize.com. That might link for you. I'm not sure. And it's going to give you a world map, and you're just going to answer some questions about the actual size of things. So remember, maps lie. Maps, especially this Mercator map, like we have on the wall here in the classroom, it lies about the size. So get out of here, you screen. Anyways, so here's what it has. Like, it's going to tell you to take over some countries. You're just going to click. We'll just do Texas. You can do. So there's Texas. We can actually see the actual size of Texas. If we move it up higher, the higher I move it up, the bigger Texas gets, because the higher you get up on the map, the more skewed it gets. So it's going to ask you to tell me what size actual things are. So you can see Texas actually fits inside of Saudi Arabia here. It's bigger than Belarus and the United Kingdom. It's huge, right? So once you do that, if you don't know where some of these countries are, just type in Texas and it says move it to Ethiopia. If you don't know where Ethiopia is, just type in Ethiopia. It'll then highlight them both for you, so you can see where they're both at. And so you drag Texas over to Ethiopia right here. Anyways, it's easy. It's just very basic questions there. So do both these assignments by Monday, and then we'll start on chapter 22 next week. Any questions, just let me know. Thanks.